Tutorials in Introductory Physics are a research-based student activity developed by the University of Washington's Physics Education Research Group. Students work in small groups to complete worksheets based on common student difficulties. CU Boulder is considered an example of a success story of the integration of tutorials into an undergraduate curriculum, having used them since 2003. We spoke with Dr. Stephen Pollock, who played a key role in this effort.
So when I first learned about Washington tutorials, I was on sabbatical. I visited the University of Washington. I watched them in action. There was clear evidence that this would be a significant improvement over Colorado's existing recitation model, which had graduate students standing in a small classroom lecturing to the students about homework problems.
Dr. Pollock and his colleague Mike Dubson used the tutorials in introductory physics for several years, starting in the first half of the course covering mechanics.
We collected lots of data. We were collecting as much data as we could. We looked at the Washington papers. We would replicate some of their published questions so that we could argue whether or not Colorado was achieving the same learning outcomes, and we were.
At CU Boulder, a large number of faculty rotate through teaching the introductory sequence.
We had this beautiful thing that happened. A new faculty member came in, and he looked at the tutorials, and he said, yeah, never mind. I'm not really all that excited.
Though that instructor did use some other small group activities. The next two instructors went back to using traditional recitations. Dr. Pollock gave a common test of conceptual understanding, called the Force and Motion Conceptual Examination, or FMCE, to students in all of these classes. In the classes using tutorials, students learned a large fraction of what they didn't already know coming into the course, called a normalized gain. In the next semester, gains were slightly lower. In the traditionally taught recitations, the gains were the lowest of all.
So we had 3 semesters of data, and all 3 of those semesters were lower normalized gains on a variety of measures. They were, enthusiastic and skilled faculty. The students just weren't learning as much. And then a faculty member came in and said, no, I really like these tutorials. I want to switch back. And the learning gains went back up again.
Instructors continued to use the tutorials, and Dr. Pollock continued to give the FMCE. And over time, a pattern emerged.
And so this was a beautiful data set, which, it turns out over time, we've seen semesters where the learning gains go back down. There's a lot of stories that impact student learning. It's complicated.
Though the average gains in courses using tutorials are higher than those which don't.
But it was a very compelling story, and there was just enough data to make faculty after that just feel like this is an obvious call. At CU, we typically don't have anybody teach that course more than once or twice. It's a big class, and so faculty cycle through it. So Physics 1, if you look at student learning gains on some standard measure, there's a big spread.
We can see the spread in the data more clearly by looking at a histogram of the gains achieved across courses. This kind of spread demonstrates how much different factors, like teacher experience, can affect the student outcomes. The data from CU is consistent with national data on FMCE gains. You might notice that all of the courses at CU achieve scores on the FMCE that are within the national range for courses using interactive engagement. This is because all courses at CU, regardless of the recitation style, use interactive engagement in the lecture portion of the course. Without tutorials and recitation, the FMCE scores fall towards the bottom of that national range of scores for interactive engagement classes. But with tutorials, FMCE scores fall towards the top of that range. And while different types of courses achieve a broad range of gains on the FMCE, the most commonly observed gains in these interactive classrooms are much larger than the gains seen in traditionally taught courses. One issue that needed to be addressed was what space was available for the tutorials.
You need to buy some equipment. There was some money involved. The chair allowed us to create the tutorial space, which is now well established.
The developers of the tutorials at Washington recommend having no more than 12 students for every TA. So another issue was how to get a large enough teacher-student ratio for the tutorials to be successful.
I talked to the folks there who are the world's experts, and I told them, we've got sections with 30 students and 1 TA. Can we do this? And they pretty much said that would be very difficult. It would require a very skilled graduate TA to run a 30-to-1 student-teacher ratio because these tutorials are designed to generate questions, and students need to get feedback along the way. You don't want to be holding their hand, but you can't let them spin their wheels for 20 or 30 minutes, which could happen if you had 30 people with one TA. So we really needed personnel, and I started off trying to get funding for more graduate TAs per section, but that proved to be logistically and financially impossible. And then we discovered that we had this wonderful synergistic opportunity to hire undergraduates.
These undergraduates are called learning assistants, or LAs. LAs are students who have taken the course before and are interested in teaching.
And they're not as expensive. And so really they allowed us to run the Washington tutorials. In retrospect, I don't think that we could have successfully used this very well-researched, very successful pedagogy if we didn't have the student-teacher ratio that LA is allowed. At Colorado, that it is now by all measures the low-energy state for a faculty member to just do tutorials. If you are assigned this course and you choose not to do tutorials, you won't get LAs. And what are you going to do for that hour a week? Whereas the tutorials, I've got a big notebook that I hand to them that gives suggestions about what to do during the prep session. So in fact, it's relatively straightforward for a faculty member to just go ahead and incorporate this. Collect data. Physicists love to see scores with error bars. Administrators like to see pass rates and some sort of simple representation that shows students are learning more and or students are happier in some measurable way. Student evaluations, maybe, or just retention rates, or numbers of LAs who are becoming educators. So I think going into this, thinking about who do I need to convince? Who do I need resources from? How can I help them to see the value of this? How do I convince myself that there is value to this new environment? It's conceivable that tutorials aren't the right pedagogical choice for your institution. Washington and Colorado are very, very similar in many ways, the student demographics and population. I find the tutorial environment it's very stimulating for everybody concerned. It's a completely different vision of how students learn physics. Most faculty, this is what they want to see. They want to see students in a group setting, like our own group meetings, arguing about physics and figuring it out.